streaming and zooming at the same time. But we're gonna try it though. All right. All right. So we have 50 people in the room. 55. Okay. I'm probably missing some student, but it will close at 12:05. But we are gonna start off by sharing the stream. Oops. Yeah. Hold on. I'm gonna share my. Oh, I have to open QuickTime. That's fine. My computer is so slow right now. Sorry, give me a second. Let me turn on the QuickTime.
Bye.
Okay, and let me share Zoom. Share QuickTime right now. Okay, good. Okay, so that's the last person I'm gonna event is Fabian. Let me see how many people are here. William's here. All right, so you guys should be able to see my stream as well while I go over the implicit derivative. So thanks for coming today. I told you there's no hurricane. You guys should. We could have me at McDonald's. But yeah, let's talk about what we're gonna do today. What we're gonna do is I'm gonna go over as much implicit derivative as possible, and then the rest of the class period you guys can go over homework if you want to. But it's gonna be an hour. We're gonna end at 1 o'clock. Hopefully you guys can see that. Let me change my templates. My template's gonna be grid. Apply. Okay. So last time we have talked about is the function there was two people invented calculus. So hold on, let me. So there's two people invented calculus. One is Isaac Newton, one's Leibniz, and so Leibniz actually have make a contribution into implicit derivatives rather than explicit derivative. So what's the difference between explicit and implicit? So first of all, let's say if you have y is equal to x squared, and if I take a derivative of this, that's going to give you y prime is equal to 2x. Everybody in this room, it doesn't matter how bad your grade is, you should know how to take a derivative of x squared. You should know how to derivative of y prime is 2x. But this is called explicit. Why is it explicit? Because this is explicit because it's y equal to. But not all function of y equal to. For example, imagine that if you have a circle equation, it's not y equal to, it's x squared plus y squared equal to 0. So that is not y equal to. So imagine that if you have, so we're gonna say this is an explicit derivative. And if it's something's explicit, then it's usually y equal to, right? But we all know like not all functions are y equal to, so some functions are a little bit different. So how about something that's a little bit different? I could have x squared plus y squared equal to 9. Does not have y equal to. You can, however, evaluate for y. You can say move the x squared to the other side and then square root both sides to get y equal to, but that's not the goal. So today we're going to learn something called implicit. When is implicit? When do we use implicit? That's probably the hardest thing for students, knowing when to take implicit derivatives. So we're going to start out like this. For example, y equal to x squared, explicit. Y equal to x squared plus 3, explicit. Now, you're going to get some type of function also look like this. X squared minus 2y to the third plus 4y is equal to 2. Now, this cannot be implicit because you cannot evaluate for y. There's no way for you to isolate this y. There's no way. Algebraically, it's not possible for you to isolate this y. So this is not possible to isolate y. In this case, you can isolate y, but you can take an implicit both ways. So we're going to talk about what's implicit and why do we think it's important. So again, the person who invented implicit derivative is Gottfried Leibniz, which is not Newton. So without Leibniz, there's a lot of problem that Newton cannot do. Okay, so Gottfried Leibniz, you probably know how to spell that name. Somebody put chat, can you tell me how to spell Gottfried Leibniz? Put on the chat. So I don't really know how to spell. So how do I take a derivative implicitly, right? And when do we use it? So when do we use implicit derivative? So when you have y to other power than 1, or x and y mixed term, like x squared y, those are times that you use implicit derivative. So when do you use implicit derivative? I don't have to tell you have to use implicit derivative. I can just tell you to take a derivative, but you have to know this is the moment you can take implicit derivative. So we actually do implicit derivative all the time. So for example, like if I take d to the dx of x squared, and that's going to give you implicit derivative actually, because if I take a derivative of x squared, that's going to give you 2x. And then I'm going to do if yesterday we talked about bubbles, this is the first bubble, this is the second bubble. The first bubble is going to be 2x to the first power. And then we're going to take a derivative of the chain rule. Chain rule is going to be x. Take x derivative with respect to x, which is going to be dx over dx. Which is, we usually don't write this down because we know dx over dx is going to be 1. Okay. So yes, somebody spelled it. Thank you, Sarah. Got. So Gottfried Leibniz. Leibniz. Okay. So they are the contribution of implicit derivative. Now, how do I take a derivative of something like says y to the cube? Remember, when you have something y to the cube, it's going to be implicit derivative for sure, because that y to the cube is y to other power than 1, right? So it's y to the third power. So how do I take a derivative of this? This is just like same as a take derivative of x squared, but instead of this, it's going to be 3y squared, like a power rule, normal power rule. And then there's 2 layers. The second layer is going to be y. So you're going to multiply by dy dx rather than dx over dx. Because this is 1, so that's why we never show it. We always show 2x. Now, anytime you take a derivative of y, then you have a chain rule. And chain rule is going to be dy dx. For example, if you want to take d to the dx of y, that's going to be dy dx. Same thing. Same thing is y to the third power. Any questions so far? Anybody have any question? This is very important. So if you have a question right now, you should ask.
What do you mean by dy over dx?
Dy over dx is who's this, by the way?
Ashton.
Okay, so dy dx is a derivative of a function y, which is a lot of people don't understand dy over dx. This means a small changing of y or small changing of x. So d means change. So that's delta. D stands for delta. Delta of y over delta of x. So basically, dy dx is the slope of the function or the derivative of the function. How do you get the derivative of a function? You have to take derivative with respect to x. So that way we can say, oh, how much you're changing y over how much you're changing x in terms of function expressions. Does that make sense?
Okay, so then how do you evaluate that? Like, how do you get that?
You're not going to evaluate anything right now, but you're not evaluating anything. You're just taking the derivative. You simply take a derivative of x squared. That's not evaluate anything. That's just derivative is 2x. You're not evaluating anything at all. You are just taking the action of derivative of x.
So is that like the final equation? Is that like the answer?
Yeah,
finding
the slope of the equation, actually. Right. But we know derivative is the slope of the equation. Okay, so now we're gonna get to a little bit harder now. So now we're gonna take a derivative of something that says x squared y. What kind of rule I'll be using if I take a derivative of the y? X squared y. What kind of rule I'll be using here?
Power rule? I mean, a product rule?
Product rule. Good. So this means these two things are times each other, right? Because x squared times y. If it's x squared plus y, then it's not a product rule, but it's x squared times y. So there's a product rule. Now you gotta be careful. If you understand this part, you can understand pretty much a lot of things about implicit derivative. So right now, I'm just gonna take derivative respect of x of the expression x squared y. So they are lefty right, righty left. So if I take a derivative of the x squared, it's gonna give you 2x. But I'm gonna leave your y alone. Okay, I'm gonna leave your y alone. And also plus, so it's two functions, x squared times y, right? So let me show you that here and here. And then now I'm gonna leave the first function alone, x squared. Now I'm gonna take a derivative of y, so here is gonna be dy dx. So slightly different. Anytime you take a derivative of x, you just do it explicitly. Every time you take a derivative of y, it's gonna give you a new notation called dy dx. Okay, so I'm going to ask you to take a derivative of this now.
What?
Okay. Now remember the constant can be all the way in the front. So when I do this, I will probably take this -6 outside the derivative. So I'm just gonna focus on derivative of this. Right? So I want you to see if you can take a derivative of that before I go over there. Remember, it's a product rule. Because now it's x squared times y, but every time you take a derivative of y, you're going to get dy dx. Is everybody done? I don't know. I think you did too. I probably didn't bring it. I didn't lose it. Nobody can take that. So I hear it's going to be -6, hopefully. And if you take a derivative of this, it's going to give you a 2x y to the 6. Because I just take a derivative of the x squared, I leave the y to the 6 alone, and now it's going to be plus x squared. Now, if I take a derivative of, I'm going to take a derivative of the y to the 6 here on the side to show you what happened. Now I'm going to take a derivative of y to the 6. It's actually 6y to the 5th times, because they are chain rule, so they were dy dx. So the notation wise is going to be 6y to the 5th dy dx. And that's it. Pretty much you're done. If you want to distribute this -6, you can. So it'll be -12x y to the 6 plus actually minus 36 x, sorry, 36 x squared y to the 5th and dy dx. Did everybody get it?
When you do like when you leave the y like alone for the first time, you try to find the derivative the second time, or because you left.
Who is this, by the way?
Yeah.
Who is this, by the way?
Gareth.
Okay, Gardas. Okay, so can you say that again?
So you left like y to the 6 like alone for the first time, and then when you do it the like derivative again, like do you leave like the y term alone for the first time, or?
Yes, you're right. So think about this left and right, right? I take a derivative of the left first, so it'll be 2x. But I leave the right alone. Is that okay? Now the second time, because of product rule, it's going to tell you righty left plus righty left has lefty right. So in this case, it doesn't matter which order it is. Some people did a different order. That doesn't matter because you're adding. So now the second time I take a derivative. Now the x squared I leave it alone, and I just take a derivative of this y to the 6. But y to the 6, you are deal with chain rule because there are 2 layers, right? So it'll be 6 in the front, y here, 5th, times the derivative of that, dy dx.
Okay.
And the rest of them just distribution. It's not like crazy. Yeah, so Gareth, good job asking questions. It's fine. I wish you do that in the classroom though, because in a Zoom you actually ask questions, but in classroom I need you to ask more. I don't mind people asking me questions, so anybody else have any questions?
Is it possible to find the derivative of dy over dx?
Yes. We're gonna talk about that second derivative, but we haven't get there yet.
So for dydx, would we ever like solve for the slope and then plug that in, or would we just leave it alone?
I'm glad that you pointed that out because that's what we're going to go next. Because right now we are taking derivative of an expression, we're not taking derivative of an equation. So there's a difference. A lot of time people don't understand what's the difference between expression and equation. So for example, this is an expression, right? 1 over x minus 1 over 2x. That's an expression. So this is an expression. So right now we only take a derivative expression. But sometimes you got this, right? This is equation now because this is an equal sign. So this is equation. So a lot of time I didn't feel like algebra 1 teacher didn't really talk about the equation and the expressions, the difference between equation and expression. Because a lot of time, like we just tell you, oh yeah, and I can stand like sometimes people says like this, and they say, Mr. A, what do I solve for? There's nothing to solve. The only thing you can do is factor. You cannot solve, right? So this is the expression. Expression you can factor. You can change to this, so you can factor it. But this is what you're supposed to solve for. If it's equal to 0, then you can solve for something. So you can factor out x minus 1 equal to 0, x equal to 0, x equal to 1. So that's that. Okay.
So would we be asked to find like the horizontal tangent or like the tangent line?
Very good question. Would I ask that? Yes, I will ask you vertical tangent. I will ask you horizontal tangent.
And it's solved the same way as explicit?
Yes, but a slightly different. But we will talk about that in a second. So we're gonna get to equation now, like how to take a derivative of equation. Take a derivative of equation is nothing different than what you're doing right now. Okay, so you are just taking derivative. Now you have an equal sign in there. So for example, y to the third plus y squared minus 5y minus 5x squared. This is a very simple one. So right now, how do I know this is implicit? Well, we have y to the third power. That's already the first thing you can notice that that's actually implicit derivative. Because y to any other power than 1, it should be thinking about implicit directly. Now, do they have mixed term? Do they have x and y? No, I didn't give you too hard on this one. I just give you a very simple one here. So you can very easy to take a derivative and move on from there. So I'm going to talk about let's take a derivative. But what we take a derivative with respect of, we also take a derivative with respect to x. So then our result is going to give you dy dx. Now, what happened is I would take a derivative with respect to x here. So I'm going to take a derivative of this function. So Amara, can you tell me what's derivative of y cubed?
3y to the power of 2.
Anything else?
You're asking the whole thing?
No. Just y to the cube alone. Just y to the cube. I only want to take a derivative of the first one. What would be the derivative of y cubed?
Oh, dy over dx.
Yes, good job. So this part is going to be dy dx. Okay. Chase, can you tell me what's derivative of y squared?
It would be 2y. Or, yeah, 2y times dy dx.
Good. Anytime you have a y, you're going to have a chain rule because y squared, you take it first there and the second there, right? So dy dx, because we're taking derivative with respect to x. If you think about x squared, you're still doing two things, but it's up 2x times dx over dx, which is this is 1. That's why it doesn't show. Minus Amber, can you tell me derivative of 5y?
-5 times dy over dx.
Yep, that's it. And somebody told me what's derivative of 5x squared, Connor?
-10x.
Okay, yeah, so is that dx over dx? Yes, they are dx over dx, but it doesn't show. And then, Kadian, can you tell me what's derivative of -4?
0?
Yeah. Okay, so Kadian, what kind of question you have?
I don't think Kadian has responded.
Oh.
This is Ian.
Oh, hi, Ian. Okay.
I don't know how the camera isn't working.
Okay, that's fine. Okay, I think Kadian has a question, but I don't know, he's not responding.
We don't have a question.
We don't have a question.
Oh, okay. They almost cut out my Wi-Fi this morning. Okay, so what you're gonna do is now you're gonna find the dy dx. How do I find the dy dx? Well, we can isolate the dy dx term. So all the dy dx term is like here, here, here. We can isolate them. So what's the best way to isolate them? Just move the 10x to the other side. Or anything doesn't have a dy dx, you move to the other side. So now you're gonna get to here, so be 3y squared dy dx plus 2y dy dx. And this is why I told you guys to solve the pig problem very, very early when we're doing prepare the algebra. Just solving for a variable, but instead this time we're solving for dy dx. So I can actually, since they all have a dy dx, what can I do next? Anybody knows what can I do? Can I isolate dy dx?
Factor. Divide both sides by dy dx?
Yep. No, you don't divide, you factor. So be 3y squared plus 2y minus 5 now equal to 10x. And then you can dy dx, you can do it to divide it to the other side, so be 10x over 3y squared plus 2y minus 5. So you take the first implicit derivative that you ever take. Now, why do we know this implicit derivative? Because it's y to the multiple power, other than 1. There's no mixed term on this particular case, but they are here. Now, some people is gonna say, hey, I think Among or somebody else, Gabby is the one that asked me, say, can I find a horizontal asymptote? Now, remember, if you want to find a horizontal asymptote, it's pretty easy. You just set the numerator of dy dx equal to 0. That will be a horizontal tangent. Now, if you ever want to find vertical tangent, so you're going to set denominator. Of dy dx equal to 0. It's going to be vertical tangent. Okay, so that's just for the future reference. For the future reference, like, so if I want to find horizontal tangent here, it's gonna happen at x equal to 0, because you can set 10x equal to 0, x equal to 0, and then you can plug in x equal to 0 into the original function, and then you're gonna have to solve for y. Even though the y is almost impossible to solve, you might need a like graphing calculator to solve it. You gotta get y cubed plus y squared minus 5y is equal to -4. You have to move all the thing on one side using graphing calculator to solve it, but that's gonna be that. Yeah, somebody else have a question, sorry.
Yeah, I had a question. So is this like implicit derivative only for y, or if you gave us like t to the third plus like another t value, would we do the same thing?
Okay, so Gabby, that's not a bad question, because that's gonna lead to the next sections. So
Okay.
So next section, we don't want to just know the rate of change in terms of graphing, which is slope, which is dy dx. Next section, we are going to take to respect to time. So that way we can know the rate of change with respect to time. So let's say how fast I'm moving. I'm moving at 5 miles per hour. Then if you think about it, 5 miles per hour, that's a rate of change of distance over rate of change of time. So later on, we're going to take the to respect to time relative to respect to x. But we had to finish this test first, which is make sure everybody did well on this test, which is it has implicit derivative. Later on, we can get to the d to the dt. Okay, now I'm going to do one very quickly. So let me know if you have any question. So I'm just going to name a question. By the way, you guys probably don't know what this graph looked like, but you should graphing on the decimals. So I'll graph it on Desmo to show you. This graph is probably looks kind of weird. It kind of look like it's not a function that you will deal with before. So let's just do that. So it's y to the 5th power. Oh no, to the 3rd power. Y to the 3rd power, and then plus y squared, and then minus 5y, and the minus x squared, and equal to -4. So it looks like this. So you do have a horizontal tangent at 0, by the way. What we talk about is -10x equal to 0. You do have horizontal tangent, and you have multiple vertical tangent. You have vertical tangent here, you have vertical tangent here, you have vertical tangent here, you have the vertical tangent there. So you have a multiple vertical tangent here. So you're gonna set the denominator equal to 0. Denominator equal to 0. If you go back to solve it, you're gonna find all this vertical tangent. You might need a quadratic formula as well to finding all the terms. So that's the things that about this. You can find horizontal tangent here from here, and vertical tangent from denominator equal to 0. Now denominator equal to 0 could have multiple points. So that's the things that you have to find out. But anyway, we're not going to there yet. We just want you to take a second simple derivative. We want you to take a derivative of this. Okay, we want to take a derivative of this. I'm gonna do this one. If you think you're very comfortable with math, you can jump ahead and see if you can do it right. But I'm gonna do this one. So I'm gonna take 30 seconds before I start. So I'm gonna set the timer right now, says 30 seconds. If you want to start, you can start. But I mean, if you feel like you're not good with math, then I won't start it yet, just because I'd rather make sure you guys have the right directions. You guys still have 20 seconds. 10 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay, I'm gonna start. So the first thing is I'm gonna take a derivative with respect to time. Sorry, derivative with respect to x. If I take a derivative with respect to x, that's gonna be easy, 2x. Not a big hassle. Now here's what I want you to pay attention. Everybody gotta pay attention to me, because this is a part that I would rather you do it right. So I will leave this -5 alone like this and just focus on the derivative of this part. Okay, x squared y to the cube. Why is that? Because I can distribute after. I don't have to deal with negative sign when I take a derivative of -5x squared. I think that's better for kids to do correctly rather than make a simple mistake. So I'll take that -5. I don't do that derivative of -5. I just do derivative of x squared and y to the cube. I'll distribute later, and I think that's going to be a lot easier for a lot of students to make less mistake. So if I take a derivative of x squared, it's going to give you 2x. Y to the cube plus x squared times x squared times 3y squared dy dx. Anybody have any questions here? Again, it's x squared y to the cube. So I take a derivative of x squared first. I get 2x y to the cube. Now I'm going to leave the x squared alone. So I'm adding x squared times derivative of the y cube, which is 3y squared. But I'm not going to forget, anytime I have a y, I must have accompanied with dy dx. And
so did you just use product rule for that?
Yeah.
Okay.
And then I only finished taking derivative of this part. That's it. I haven't taken derivative of -y squared yet. So that's the derivative of -y squared. So it'll be -2y dy dx. And derivative of 5, you know what? A lot of people make mistake taking derivative of 5. The derivative of 5 is a constant. So just 0. Some people still write down 5. That's why they got a wrong answer. So, and then plus dy dx. Now, if you realize there was a dy dx on this side, there's dy dx on this side, there's dy dx on this side, The best idea is make sure you distribute everything and move all the dy dx term on one side so we can factor out. So I'm going to go ahead and do that. So it'll be 2x minus 10x y to the cube minus 15, because 5 times 3 is 15. Let me know if I make a mistake, because I would rather know now. And like this, -5 times 3 is -15, x squared y squared dy dx, minus 2y dy dx is equal to dy dx. Got it? Now you see that dy dx term, there's a couple on the left side, there's a couple on the right side. I feel like it's better to move all dy dx term on the right side, because on the right side has a mixed term, and I already have a dy dx on the right side, so I'm going to move this to the other side. Move this to the other side. Well, they move, that becomes plus, because start with negatives. So that's going to be 2x minus 10x y to the third is equal to dy dx plus 15x squared y squared dy dx plus 2y dy dx. And I'm going to factor out dy dx afterwards. But if you factor out, this must be 1 plus 15x squared y squared plus 2y, and then 2x minus 10x y to the third. And then now you can isolate dy dx by divide everything to the other side. So it'll be 2x minus 10x y to the third over 1 plus 15x squared y squared plus 2y equal to dy dx. And this becomes your new notations. Okay, so what I'm going to do, any questions before I go? Not go, but we haven't finished yet. So I think the best trick is to leave that -5 outside and take a derivative of just x squared y to the third. I feel like that you make less mistake there. Anybody have any question? So I'm gonna give you one, and you guys gonna take a derivative of that. So I'm gonna get negative 5x squared y to the third plus y squared is equal to 10x minus 2y squared, or minus actually 2y plus 25. I want you to find dy dx, and I'm gonna let you guys talk to each other. So I'm gonna create a break room. I'm gonna create 6 break room. Hopefully everybody have some strong, every group is gonna have some stronger group. So let me see if I can create student. I don't know who Zoom user is, so I can't really give you credit if I don't know who are you.
That might be me. I'm here, but the thing doesn't work right.
Okay. Yeah, it seems like every group has somebody who's fairly strong. I might rearrange a couple people. So there's 6 group here. The first group leader is gonna be Lucia. Second group leader is gonna be sure. I'm gonna change room to second group is gonna be Eli. Third group is gonna be Nearly. The fourth group is gonna be Armand. And the fifth group is gonna be Luke. The sixth group is gonna be Shaylin. The sixth group is actually pretty strong. Shaylin just come back in. So I'm gonna open auto room. You guys can go to breakout room and talk about your answers.
How do you go to the break rooms?
Just say join break room.
It doesn't say join break room on my screen.
I don't know. Oh, because I'm gonna assign you to room 6.
Yeah.
Hayden?
You guys get an answer yet?
Yep.
Yeah. What did you get?
I got 10x y cubed minus 10 all over 15x squared y squared minus 2y minus 2.
Okay, I kind of got that. I just got like different signs and orders.
Yeah, me too.
Yeah.
Okay.
Okay, cool.
Double check with each other, make sure they're right. Hi, Ava.
Hi, Mr. Ye.
Coming kind of late.
Okay, well, I woke up and then I forgot, and then I woke up again. Now I was like, I was Zoom call to be on, so now I'm here.
Oh, okay. All right. Well, I still see you.
Yes.
Okay. Sarah, are you doing okay? I haven't seen you for a while. You sick?
Yeah, I lost my voice, so I can't talk in the thing.
Laura, I don't see you. I see a black screen.
Yeah, actually, like, I'm outside right now. I don't think my camera is working.
Uh-huh.
Yeah, but I'm doing great.
Are you sure? Did you guys finish your answer?
I'm on my way to doing that right now.
Katie, which Katie is this? What Katie is the Vietnamese Katie or Who's that? Tyler. Oh, the white kitty. Of course. Tyler, you can help her with the implicit derivative. Are you guys doing okay? Luke, are you finished?
Hello, Mr.
We
J.
all finished.
Austin! I like the
I've
hat.
been here.
I like the hat.
I didn't get ready this morning, so it has to stay on.
Mm. Well, Trent is at least like class, which is. I don't see some of you guys. Caroline, Jenny, where are you, Jenny? Hi, Caroline.
Oopsie. I don't know how my audio is though. Is it like cracking or anything?
No, it sounds nice.
No? Okay, great.
You guys finished
Did I
checking the
have
answer?
10 on?
You guys finished checking the answer?
Yeah, I think.
Just so the first in the beginning, we're just gonna find the derivative of everything. So I can't really hold up my notebook. It's not a notebook, it's a binder.
Okay, fine.
Brendan, what the hell are you doing?
Who?
Brendan.
Oh.
Okay, I don't really need to see you doing dance move there.
I don't think you can hear anyone else.
Yeah, he said he can't hear anyone.
Guys, just out of curiosity, is it raining a lot where you guys are at?
No. The
Not
wind
at all.
is big.
Not at all.
They should not take today off. They should take
Yeah.
tomorrow off, maybe.
You think they're gonna give us a day off tomorrow, Mr. A?
What's up, Hazen?
I don't know.
They would have said it by now.
They supposed to send an email. They supposed to send a message.
Well, the winds are gonna get bad.
Exact thing we did.
Okay.
How you guys doing?
Good.
Okay.
Good. The only thing is, I got the same answer as him, except like everything was inverted. Like every positive he had, I had negative, and then like vice versa.
That's
So
fine. As long as everything's inverted, it's fine because you can factor out a negative sign and cancel the top and bottom and make it exactly the same.
oh, okay. But if I had left it like that on a test without like fully simplifying it, would I get it wrong?
No, it's fine.
Okay.
It's not fully simplified. It just sometimes you move in the different directions.
Yeah,
So
because we moved it in opposite directions, and so mine was like the opposite of his.
Yeah.
Okay.
All right, I'm gonna close out the room.
Okay.
And so we return. Hello.
Hi.
Okay, so I want to talk about one more concept, which is student mess up that one as well. So, but that one I'm gonna guide you through everything. So this one I'm gonna go ahead and do it really quickly. So -5, -5 times 2x y to the third plus x squared times 3y squared dy dx plus 2y dy dx is equal to 10 minus 2 dy dx, and that's gonna be that minus 10x y to the third minus 15x squared y squared dy dx plus 2y dy dx equal to 10 minus 2 dy dx. Now I'm moving 10 to this side, 10 to the left side, so it'll be negative 10 x y to the cube. Am I doing okay so far? Okay. Sorry, I'm just doing kind of quick because I want to talk about one more question before I go. Now, I'm moving dy dx to the other side. So here I'm going to factor out dy dx. And here I'm going to get -2 plus 15x squared y squared. I just do kind of do 2 in one step. Minus 2y. So far, am I doing okay?
Mm-hmm. I think you
forgot
forgot
to move the 10.
on the right. Yeah.
It's 10 negative 2 dy dx.
Okay, so hold on a second. I missed a 10, right?
Yeah.
I missed 10 somewhere, so this should be negative 10.
Or on the left, yeah.
Negative 10, right? Yeah, I did forget about that. So then you got dy dx equal to -10 minus 10x y to the cube over -2 plus 15x squared y squared minus 2. Now some people do get different signs, so let's just say 10 plus 10x y to the cube over
One of the two should have a y on it.
Which one?
One of the two should have a y on it. Because when you factor out dy over dx,
you're talking about this y, right?
Yeah, I need 2y. And like, yeah, one of them should have a y.
So here it should be 2y.
Yeah.
Okay. So thank you. So here you could have this negative 15x squared y squared plus 2y. You could have everything switch sign, because imagine if you factor out a negative sign here, imagine you factor out a negative sign, but both negative sign will cancel out. It becomes positive, and that's what's going to be. Now we're going to talk about last question. Last question is another test question. All this question could be on a test. So last question was kind of hard because a lot of time people have problem with the arguments. So is sine of x plus y squared equal to, I don't know, 3y, something like this? And I say, hey, I want to take an implicit derivative. Now it turns out that there was a chain rule here. So this is the first outer layer, and there is an inner layer. And if you guys still don't understand chain rule, go watch yesterday's video. And then I'll take a derivative of y. So here I'm going to take a derivative of the sine. So it'll be cosine of x plus y squared. Remember, they cannot distribute because that is an argument. You never touch your argument. So it's just cosine of x plus y squared. It cannot be cosine of x plus cosine y squared. It cannot. If it does that, you're automatically wrong before you start. So make sure you do not distribute, because this is how you take a derivative outer layer. Now I'm going to take a derivative inner layer. It's going to be 1 plus 2y dy dx. And I'm going to take a derivative of the other side. It'll be 3 dy dx. Now, what people need to understand is this is one argument. And they do not break down, but they can distribute. So I'm going to distribute to here and distribute here. So it'll be cosine of x plus y squared. And this is one of the most common missed questions for the next test. Plus 2y dy dx, because people just don't understand the argument. Equal to 3.
How did you get 1 plus 2y dy dx?
Because I take a derivative inside. Derivative of x is 1. Derivative of y squared is 2y dy dx. And then now I'm going to isolate them, but I'm going to move all the dy dx term to the other side. So it'll be cosine of x plus y squared is equal to 3 dy dx minus 2y dy dx times cosine of x plus y squared. So I move this to the other side because this one has dy dx. I move to everything to the other side. I factor out. and I'll solve it. 3 minus 2y cosine of x plus y squared over cosine of x plus y squared. Now, remember, please do not try to be cute. Says, oh yeah, I want to cancel out this. This is not cancelable, by the way. That
You
is.
flip it the wrong way.
Yeah, isn't it flip the other way?
Yeah, I did.
Since you divided.
Thank you. Sorry, I did it too fast. This is flip, so it's gonna be cosine of x plus y squared over 3 minus 2y cosine of x plus y squared. And do not try to cancel this, because if you cancel that, it's wrong, because that is not a factor. Okay. Before I go, this is probably two of the three questions on the test. If you understand everything today, it's gonna help you with two of the questions. The third question is the second derivative, like Armand want to talk about, is the second derivative. The second derivative is gonna be the one that is gonna be a little bit more difficult. But if you understood everything today, you should get at least 2 questions on your test correctly. Yes, Nick?
Oh, Mr. Yeah, will there be extra credit on the test?
Will there be extra credit on a test? Who's this?
Nick.
Nick who? What's your last name? No idea who that is. Do I have a student named Nick? Yeah, Mara.
Can you explain how you went from like how did you get the cosine parentheses plus 2y dy dx, like the second line? Can you just explain that?
Are you talking about this part?
How did you go from that part to the line below it?
I distribute.
Okay.
So okay, I distribute the whole thing.
Okay, you distribute both sides? Yeah, because I was wondering the same thing.
Yeah. Is that okay?
Mm-hmm.
Okay.
Uh-huh.
For the test, would the questions be like find dy over dx, or would it just be like find the derivative?
That's a great question. I would just say find derivative, and you have to know when to use implicit. So in this question, I know it's implicit is because y to the square, or anytime you have x squared y is mixed term, then it's implicit derivative. Then you have to know when to use implicit derivative. Oh my god.
Not a concepts question, but I couldn't see what you wrote on one of the pages earlier.
Sure.
When you were writing when we used implicit derivative.
This page?
Yeah. X and Y something. I couldn't read those two words.
X, Y mixed term. So if you have x squared y, then that's you use implicit. Jenny?
So when finding the implicit derivative, we just find the dy over dx?
Yes. Well, we will say we'll find derivative, that means dy dx, but the sum function you have to use implicit derivative. Some function you don't.
Okay.
Okay, that's it. Have fun on Hurricane Day, and hopefully see you tomorrow. And if I don't, then I might have another section. I don't know.
Bye.
Bye.
Wait, are you in Brendan's house? Is everybody in Brendan's house?
We're at Caitlin's house.
All four of us.
In Kevin's house?
Kalen.
Kalen's
My house.
Oh.
Kalen has mono, bro. I'm not going to his house.
Are you gonna try to kiss me or something, bro?
I don't know. You guys are kind of sus.
Bye.
Bye.
Bye, Mr. Ye.
Mr. Ye,
What's up, Aizen?
are you gonna be sending us homework through the group chat?
No, you guys already have homework. You should finish the other homework first because the other homework is kind of long.
Okay.
So I'd rather you finish that. But if I see like tomorrow no school, I will send like an implicit derivative practice. So that way
Thank
you can
you.
practice.
Bye.
Bye, Mr. Ye.
Bye.
See you, Mr. Ye.
Bye, Mr. Ye.
Bye.
Bye, Mr. Ye.
Bye, Mr. Ye.
Bye.
Bye, Mr. Ye.
Bye.
Bye.
Bye, everyone.
Luke says bye, Mr. Ye.
Bye.
Bye, Mr. Ye. Have a good day.
Wait, Lucas.
Bye, Mr. Ye.
Bye. A bit. Stop playing Roblox.
Can I learn optimization with BC?
you want to learn optimization of BC? Wait, what?
Sure.
Wait. Oh,
Wait.
okay. That's Nick. I know I don't have a person named Nick. What the fuck?
Charlie. Hey, Mr. Ye.
Charlie,
Oh, hey,
where?
Charlie. How do you got my Zoom link?
Magic.
Oh wow.
We learned a lot today.
How is a UF?
Pretty good. Calc 3 is very quick.
Is it easy or hard?
It's not. It's easier than Calc 2.
Really?
So far. So far. We just started partial derivatives.
Okay. And Charlie, I thought you were going to medical school. Why are you taking Calc 3?
I'm an engineering major.
Why are you engineering medical school?
I don't know. I'm switching next semester.
What are you switching to?
Biochemistry.
Oh. And you're gonna do medical school?
Yeah.
Can you run over to the honors village and meet Bryce?
Oh my god. Why do you like Bryce?
Do you guys still hang out in college?
Yeah. I mean, I'm wait with Bryce or me and Ahmed. Kind of Ahmed's roommate, so.
Okay. Oh yeah, that's true. That's true. That is true. Yeah. I was like, who the hell is Nick? I don't have no student named Nick.
I couldn't think of a last name. That was funny.
So also you be quiet. I was like, I have an imposter in my class. I know for sure I have an imposter in my class. Your sister's doing slightly better. But
Oh, that's good.
But still not you.
Yeah, I know. I keep getting the emails from Gorberg.
Why are you getting the email? You're his parent?
No, it's the parent email.
Oh.
The family email.
Family email? Okay. All right. All right. Well, good luck. I have another BC optimization we have to talk about.
Okay.
So go away.
Okay. Okay. If you see Nick again, you know where it is.
Are you guys still playing ping pong?
Sometimes, not as much.
Oh.
We play more pickleball.
I have nobody to play ping pong with.
Oh, you're Jared. Oh, he's not in your class.
No, Jared only show up like Jared show up on Friday. That's it. But I have a ping pong machine now.
Oh, it's Christian. He's joining. Oh shit! Oh wait. Wait, it's the same Zoom. Yeah. Probably.
So in this section we have a TA, Amil. The TA is gonna guide this lesson today.
What did he say? You should optimization. We did it.
What'd you say? Man, UF football team kind of sucked this year.
Yes. Yeah.
Have you guys went to the game?
Yeah.
Yeah, but it was a disaster. I read Steve Spirit was in the game, and he left early, and he said the game is horrible. Steve
Oh.
Spirit is a coach in
yeah,
1980s.
Yeah.
And he left early in the game.
Tebow was there too.
Tebow's there. That's so sad. Like they hire a coach that's so crappy. I heard a stadium start calling, says like, "We want Lang, we want Lang."
I think so.
So Lane Kiffin is apparently did pretty good in Ole Miss.
Yeah, they keep chanting to fire him, the coach.
Sucks. Khrushchev, turn on your camera on.
Hello, Mr. A. What's up?
We got a TA here, Amio.
How are you doing, bro?
What's up? Charlie's right here too.
Hi, Charlie.
Where's your camera, bro?
It's not working right now. I'm gonna fix it a little bit.
Okay.
We'll start in like 5 minutes. You know a bit, Amio?
I do.
Yeah.
He's playing Roblox.
I'm not playing Roblox.
Have you guys go to party in UF?
Oh, I have.
Amio, you haven't gone to party yet?
I was at one last night.
Oh, okay. Are you guys gonna join any fraternity?
Oh. Yeah.
No fraternity?
Okay, TA is going on lunch break. I will see you, Mr. Yu.
Okay, bye. He is on lunch break. Hey, you guys gotta turn on camera. I turn on mine. I hate talking to black screen. What's up, Ethan? Turn on the camera. I'm gonna kick you out. I don't want to talk to a black screen. I have PTSD from black screen. All right, so optimization. I'm gonna send a worksheet over in a second, so that way, you guys have any question, you can start off. Sophia, you walking a dog or what?
Yes, I'm trying to get my dog back inside.
Okay. Well, you guys don't need to be here, only if you don't know your optimization. So it's not a problem. I know Elise and Sophia and Nora should be pretty good. But only if you guys want to. So we are gonna start with optimization. So what I'm gonna do is I'm gonna start with a worksheet. So I'm gonna send it through here. I'm gonna send it on a group chat. Group chat plus photo, manage, select more photo. Okay. So we're gonna start with this problem, those two problems. So we're gonna start with the question 3. Question 3 should be pretty easy. So Kashif, wait, where's Jing? I need Jing to be here. Kashif, Raphael need to turn on camera, Nor, Oswell. It's okay, don't be shy. Tanner, turn on camera. I just don't like talk to black script, no offense, but I really have a nightmare still teaching like COVID year. Okay. You guys got a question, right? No? Maybe not. Sorry. I thought that. Question 3. There we go. Now I'm also gonna send you a little bit higher level of optimization worksheet.